EDX Decision 1, Critical Path Analysis 2, Scheduling, using Gantt or cascade charts. Finding the minimum time taken to complete a project from an activity network assumed that there were enough people and equipment to deal with more than one activity taking place at the same time. In practical situations, of course, this is not always the case. Equipment may be required which perhaps cannot be used for two activities at once. Example, in a cooking project, perhaps two items need to be cooked at different temperatures. In addition to activity networks, you need other ways of analysing projects which allow you to consider how the scheduling affects the resources, usually workers, that are required. We will look at how to use a cascade chart to draw conclusions about the scheduling effects the resourcing required. Note, here we can assume each activity requires one worker. Here is an activity network and its precedence table. Assuming that each activity requires one worker, how many workers does the project require? We can work out a lower bound for this by taking the total time for the project and the total time of all the activities. And if we take the total time for all the activities, which in this case the total duration is 32. If we take 32 and we divide it by the duration of the project, which is 15, we get approximately 2.1. In other words, we need 3 workers minimum in order to complete this project. 2 workers wouldn't quite be enough, but 3 workers minimum is required. Here's a completed cascade chart for the network shown. We can see all the activities, we can see the durations, and we can see where the available float is. Notice the critical activities A, D, G are all together in a line at the beginning. How many workers are required at the moment? And we can check that by looking at each time interval. So at the beginning here, this would be 3 workers, 3 workers, 3 workers, 1, 2, 3 workers. If we look here, it appears that we need 1, 2, 3, 4 workers. So at the moment it appears as though we need 4 workers. However, we could do this with 3 workers if we can avoid this clash at this point. And we can avoid this clash here. We can avoid this clash if we just move F 1 unit forwards. So if we bring F 1 unit forwards, so we don't need that first unit at the beginning, there's no clash anymore, and we can do this in theory with 3 workers. We're now going to look at 2 possible extension questions. Activities A and B both require the use of the same piece of equipment. Can the project still be completed in 15 hours? And question 2, A and C must both be done by the same qualified person. There's only one qualified person. Can the project still be completed in 15 hours? So A and B both require the same piece of equipment. Can the project be completed in 15 hours? You might want to pause the recording at this point to see if you can come up with a solution. So at present, A and B are scheduled at the same time, but they both require the same piece of equipment. Since A is critical, moving A would affect the project delay. Therefore, the best option would be to move B. And moving B means that E and F must also be moved. So we'll see this happening now as we move B. We can see E and F being moved. The project can still be completed in 15 hours. Question 2. A and C must both be done by the same qualified person. There's only one qualified person. Can the project still be completed in 15 hours? So we can see A and C on the diagram. They cannot be scheduled at the same time. Again, A is critical, so it is better to move C. Neither E nor F depend on C, but G does depend on C. So when we move C, we will also have to, at some point, move G. And we can see from the diagram, G follows C, D and E. So moving C will require the movement of G. Can C be moved by 2 hours? Yes, that's okay, but we need to move it a little bit more. But if we move it a further hour, to avoid the overlap with A, we need to move G as well. The project cannot be completed in 15 hours, but will now take 16 hours instead. That brings us to the end of critical path analysis 2, scheduling.